All right, guys, welcome to lesson 3.4. We're going to talk about some properties of limits today. We're going to use those properties to evaluate expressions that have limits in them. And we'll also spend a little bit of time on a special one called composite functions. Doing limits with those is a little bit slightly trickier, but we'll see what it looks like. All right, so here's all the properties. This is like a mess of letters, right? So what the heck does all of this stuff mean? Well, I think once you start seeing the examples, you'll see what these mean a little bit better. But I will take a moment to try and explain them a little bit as they appear here. So let's say that we have two functions, f and g. And let's say we're going to find the limit of each of these functions as x approaches c. So the limit of f as x approaches c is L. And the limit of g as x approaches c is k. All right? Well, here's one property then. If you take the limit of f, but f is being multiplied by b, then you still get the same limit L, it's just that now the limit's being multiplied by L. So basically, if you just take this limit here, and you multiply the inside by a b, the output will be multiplied by a b. And we call that a scalar multiple. You don't need to memorize the name. Basically, it does the same thing as like we learned with derivatives, right? Whenever we had derivatives with a constant in the front, what happened? The constant just came out of it, right? Or whenever we did integrals, when we integrated functions that had just a constant, what do? We just pulled it out because the constant didn't really do anything. It just kind of stayed there. The same thing applies to limits. And the reason why they all have the same properties because both derivatives and integrals come from limits. So the reason those properties apply to derivatives and integrals is because really of this rule here, it applies to limits. So there it is. Let's take a look at another one. If you have two functions that are being added together and you want to take the limit of the whole thing, well, that's just like taking the limit of each one separately. So if you take the limit of f, you get L, and then if you take the limit of g, you get k, and then whatever it's telling you to do inside in the middle here, that's what you do to those limits. Okay? So it's like a distributive property, if you will, but they call it the sum and difference rule. Next one here, we have product. Not surprisingly, all you do is you take the limit of f, you take the limit of g, and multiply those limits together. Same thing with division. Limit of the top, limit of the bottom, you get L over k. Now this only works though so long as the limit of the bottom k, so long as that k is not equal to 0, because as you guys know, you're not allowed to have 0 in the denominator. If that happens, you would have to say no solution. And then finally, it applies to powers also. So if you take the limit of f to some power n, well, it's just going to be, you take the limit of the f, which is L, and now L is going to be raised to the n instead. So it's actually, it looks like a huge mess of letters, but actually all these rules are fairly intuitive. Let's go ahead and take a look at some problems that we're going to be giving to you guys to practice using these properties. So first, before we begin the problems, which are over here on the right side, let's take a look at the given information. They're giving us two limits. They're telling me that the limit of f as x approaches c is 2/5. They're also telling me that the limit of g as x approaches the same value gives me another limit of 2. Okay, so let's go ahead and take a look at number 1 now. Well, we saw from our last one that basically we're just going to take the limit of f, which as you guys can see here is 2/5, right? But since there's a constant in the front, that constant just stays there. And now we have 5 being multiplied by the limit of f. And since we can simplify that, we end up with just 2 as an answer. Pretty straightforward. Here's probably a better way to show the work. You can just think of it like we always have before, where you take the constant multiple out. Just pull it out of the whole problem there. And write it like this. So imagine taking this and moving it to the front. And then this piece here is 2/5. And then these cancel and you're left with 2. I think that's a much better way of showing the work. So I probably should have done that. All right, let's go ahead and take a look at number 2 here. For this one, we're just going to take the limit of each of these things separately. So we're going to have the limit of g of x as x approaches c plus the limit of f of x as x approaches c. So as you can see, all I did was it's kind of like distribution, if you will. Okay, so I just put the limit with both of those. And now we know that the limit of g is 2. We know that the limit of f is 2/5. And we could just leave our answer like that. Or you can go through the trouble of getting a common denominator. 5 on the bottom. That up. And you can get 12/5 as a one answer if you want to put those together. All right, let's go ahead and take a look at number 3. Once again, it's a little bit like distribution, only it's a little different too. But in this case, we're just going to take the limit of g of x as x approaches c. And then we're going to take the limit of f as x approaches c. And when we're all done, we're going to multiply those. So the limit of g is 2, and the limit of f is 2/5. And so the final answer would be 4/5. All right, let's go ahead and take a look at number 4. We're going to take the limit of g as x approaches c. We're going to take the limit of f as x approaches c. And so we end up with the limit of g being 2 and the limit of f being 2/5. And as you guys know, we don't like to leave our answers like this, so we would multiply the top and the bottom by 5 to cancel out that 5 on the bottom, and we end up with 10/2, which is 5. Final answer. All right. Next one, number 5. We're going to go ahead and take the limit of g there. C, of course. And now that's going to be getting squared. So just basically slip the limit there inside of the parentheses. So the limit of g of x as x approaches c is 2. We have 2 being squared, which is final answer 4. That's it. Not too shabby. Not too shabby. Let's go ahead and let you guys practice some of those. Go ahead and pause the video here, and well, there you go, the student practice. Now go ahead and pause the video here and see if you guys can get the solutions of these 4 problems. And when you unpause the video, you will see the solution. All right, so if you take the limit of f here, you get 4, so you have 5 times 4. And the limit of g is -1, so you have 2 times -1. And when you put all that together, you should have gotten 18. For this one, taking the limit of g and limit of f and then multiplying them together, we end up with -4. Taking the limit of g, get -1. The limit of f is 4. So putting them in a fraction form, as we see written here, we end up with -1/4. And then finally, we have the limit of g of x squared. So we take the limit of g of x, which is -1, and when you square it, it becomes a positive. All right. So we're going to go ahead and do the same thing now, but instead of me starting off by giving you some specific limits, we're going to look at graphs to do the same thing. So in the notes section for today online, now I'm not too sure if I put this in your guys' packet that you picked up at school. So if I didn't, you're going to want to print this out or have it at least ready while we go over these things. But let's bring up this little thing here. There should have been a note sheet that looked like this, and it had a bunch of questions on it. Okay, and so we're going to go ahead and start going through example 2 at this point on this thing. All right. So for example 2, we're being asked to find the limit as x approaches 3 of f of x times g of x. And you guys will notice that whenever I was going over the example 1 problems, I did some extra work. Like for instance, this, I would rewrite it like this. It's kind of like distribution, right? But some of you guys might have realized you don't even really need to do that. You're just basically going to find the limit of both of those and multiply them together at the end, right? So why write this step? Well, it's up to you. Maybe you need to write it, maybe you don't. It's just a technically a good way to write our answer, but or at least show our work. But it's not really a huge deal. But for this case, when I'm teaching, and I do like to do it. So let's go ahead and find these. So first of all, we're being asked to do this, right? So I want you guys to understand that means we need to find the limit of f, and we also need to find the limit of g as x approaches 3. Now, we've done limits on graphs before, so hopefully that's not too perplexing to you. Remember, whenever you're approaching 3, you have to be coming from the left and from the right. So we have the graph of f over here. So if I want to find the limit of f as x approaches 3, first of all, we need to find where 3 is at. 3 is right here. And as you guys can see, whether you're coming from the left or from the right, they both meet at the same point, and they therefore both have the same y value of -1. Now let's find the limit of g as x approaches 3. As x approaches 3, there's my point, and whether you're coming from the left or from the right, you're still landing at the same point, which is a y value of 1. And so the limit of f times g is the limit of f times the limit of g, which is -1 times 1, which is finally an answer of -1. Go ahead and take a look at the next problem for example 2. We got a couple to do here. So for example 2, number 2, we have to find the limit as x approaches -3 of f of x minus g of x. Okay, so what that means then is if I'm trying to find the limit of this entire thing, basically I need to find the limit of f as x approaches -3. And I also need to find the limit of g as x approaches -3. And then I need to subtract those two results. So now that we've got that, what's the limit of f as x approaches -3? Well, here's -3 on the f function. And it's approaching the same point from the left and right, so the limit exists. And the y value, which is the limit, must be -1. So -1 for that one. Then we bring down this minus. And now we need to find the limit of g as x approaches 3. So once again, we're right here. So once again, from the left and from the right, we're still approaching the same point, which means the limit exists. And the limit is the y value of that point, which is 2. So now we have the limit of f minus g is the same thing as the limit of f minus the limit of g, which is -1 minus 2, which is a final answer of -3. Right. I think we have one more problem that we're going to do. Now we're on example 2, number 3. And we're being asked to find the limit as x approaches 1 from the right, which is what that little plus means, of f of x over e of x. And as you guys know, that means I need to find the limit of f as x approaches 1 from the right. And I also need to find the limit of g as x approaches 1 from the right. Okay, so let's do that. The limit of f as x approaches 1 from the right. So here's where x equals 1 is. Now I've got 2 points to choose from. I've got one up here, and I've got one down here. Now since I'm approaching 1 from the right, we're coming from this direction. And so the y value that I'm approaching there is 0. We do the same thing for g. So let's find where g equals 1. So g equals 1 right here for the x value. And we're approaching it from the right. Doesn't really matter though, because in this case they're the same. But I'm approaching it from the right, and I land here at this y value, so that's -1. So the limit of f over g is the same as the limit of f over the limit of g, x approaches 1, which is the same as 0 over -1, and therefore my final answer is 0. Okay, and so that's how you do the limits with the graphs. And Whether or not you want to write out this intermediate step is up to you. It doesn't really matter. But if it helps, then go ahead and do it. But at this time, I have you guys go ahead and pause the video here and do these 3 problems. Okay, when you unpause the video, you will see the solution. All right, so here's the final answers. Number 1, you should have gotten 4. Number 2, there is no solution, so we'll put does not exist. Number 3 is 1. Number 2 was a cheap shot, Mr. Bailey. None of your examples had that. Why would you give us one like that? Well, that's okay. We'll explain it now, and hopefully it'll stick in your mind. Here we go. Number 1. So the first thing I'm going to do is I'm going to apply the property of the limits. I'm going to distribute this limit into both of these. So we have 2 times the limit of f plus 3 times the limit of g. That's the same thing as what we have over here. Now the limit of f, as you guys know, is 2, and the limit of g is 0. And then when you simplify this expression, 4. All right. Let's go ahead and take a look at the next one here. So if I want to find the limit of f times g, I need to find the limit of f, and then I need to find the limit of g, and then I need to multiply those. But as we're looking at this, let me erase some stuff here if I can. I didn't want to do that. All right, never mind, just a second. All right, there we go. As we look at our graph up above there, let me scroll back up. For number 2, if we're approaching -1, which is right here, well, the limit doesn't exist because from the left and from the right are different. So the limit doesn't exist for f. So since the limit of f doesn't exist, even though the limit of g is 1, you can't multiply 1 by something that doesn't exist. So your final answer doesn't exist. So there you go. So if you ever have a D and E as part of one of the pieces there, then the whole thing doesn't exist. Right. Now for number 3, the limit of f as we approach 2 from the left is 1, and the limit of g as we approach 2 from the left is 0. So if you guys had trouble finding the limit of f as x approached 2 from the left, and the same thing for g here, I'll show you how they are 1 and 0. Clean this up a little bit and come back up here. So if I want to find the limit of f as x approaches 2 from the left, well, here's where 2 is at, right? Now, so it's either this point or it's this point. And since we're approaching from the left, it's going to be the one on top. And so that's 1. Why that one's 1. As for the other one, we're approaching 2. But this one doesn't really matter whether you're coming from the left or right. They're both meeting at the same spot here, which is y equals 0. So the limit of g as x approaches 2 from the left. So just in case you were wondering about those ones. Okay, let's go ahead and move on to our next set. But before we do, let's talk about the limits of a composite function. All right, so first of all, let's say that the limit of g as x approaches c is L. Also, let's say that the limit of the limit of f as x approaches L is just f of L. All right. Well, let's go ahead and see how this works. So here's the main property right here. If you're taking the limit of a composite function, then what you're going to do is the limit is going to affect the inside function most of all. So if you're finding the limit of this composite function, really as x approaches c, x is going to be approaching c for the g function most. So basically just take your little limit here and put it right in front of the g on the inside function. You've got the main property. That's the main property. Now, after you do that main property, it's pretty simple from there. The limit of g of x as x approaches c is L, right? So I could replace this whole thing with L, and now I've just got f of L. Okay? So that's kind of the idea there. Let's go ahead and bring it to work for us a little bit here, and we'll take a look at a quick little example. Let's do example 3A now. This one's not in your notes, so you might need to write this one down by hand. I just recently added this slide this year. So right now they're asking me to find the limit of this composite function as x approaches 2. So the first thing I'm going to do is I'm going to take my limit and I'm going to put it in front of the inside function there on the inside. Okay, and if I do that, it's going to look like the following. Like that. Now from here, we're going to figure out, okay, fine, so what's the limit of f of x as x approaches 2? Well, we see from here that the limit of f of x as x approaches 2 is -4. So I'm just going to replace that then with -4. But we can go a little bit further because we see here that g of -4 is 8, so the final answer is 8. Now you guys might be wondering, well, what's the point of this here? We didn't seem to use this at all. Well, it doesn't matter in the process we're using, but yet it matters completely in whether or not we're allowed to do this. So just because g of negative, we remember from an earlier lesson, just because the function exists at -4, that doesn't mean that the limit exists. So in order to do this property, these limits have to exist. Now, kind of get into that little detail when we look at the graph perspective. But for now, simple enough. Let's ignore it. Let's just say, okay, take your limit, put it on the inside, figure out what that is, replace it, and then you get your final answer in the end. All right, so let me bring up a student practice for you guys. So here's one for you. Go ahead and see if you guys can figure out the final answer here. Okay, so final answer on this one is 0. We're going to take the limit and put it on the inside function there. Then we're going to find what's the limit of g as x approaches 1, and according to this, it's -5. And then that leaves us with f of -5, and up here, f of -5 we see is equal to 0. So the final answer is 0. All right. Now we're going to do the same thing, but we're going to do it with, back to this sheet here. We're going to have you guys take a look at example 3 with me here. Okay? So let's go ahead and do example 3 really quick. All right, so for example 3, we're being asked to find the limit as x approaches -2 of g of f of x. Okay, so step 1 is to rewrite this, where we're putting the limit on the inside function there. Now what we're going to do is we're going to figure out, okay, well, what's the limit of f of x as x approaches -2? So there it is. At that point, the limit exists, and the limit is the y value, which is 0. So I'm going to replace that boxed portion there with 0. And now I basically just need to find out what's the y value of the g function at x equals 0. Well, here's where x equals 0 on the g function, and the y value at that point is also 0. So the final answer for that one is 0. So it's the same process. It's just that instead of me telling you the answers, you have to find them on a graph. So now it's your guys' turn. I'm going to ask you guys to go ahead and pause the video here and try to do student practice 3. Find the limit of f of g of x as x approaches 3. And when you unpause the video, you will see the solution. All right. Darn you, Mr. Bailey, you've done it again. It's another does not exister. Okay, so first of all, we're going to take our limit and apply it to the inside function. So we have f of the limit of g as x approaches 3. Now if I look down here at my g function as x approaches 3, that's going to be like right here at a y value of 1. So the limit of g of x as x approaches 3 is 1. So what's f of 1? Well, at x equals 1, the f function does not have a value. Both of those are open dots. And honestly, even if one of them was closed, it still wouldn't exist. And it's because, remember how we said earlier in our little notes that even though it seemed pointless to have this here, it's necessary. The limit has to exist for this whole rule to apply. Okay? So, since the limit didn't exist for the f, then even if one of these dots were solid, you still couldn't have an answer. You would still have to say does not exist. All right, now we're going to add an extra layer of difficulty now. We're going to do one-sided limits. Okay, we're going to be doing some one-sided limits. And that's gonna add a new interesting twist to things here. So let's go ahead and take a look at example 4, number 1 here. All right, so we're being asked to find the limit of f of g of x as x approaches 4 from the right. Okay, well, as you guys know, the first thing that we do is we go ahead and put that limit on the inside. So we're taking the limit of the inside function. All right, now we're going to find what's the limit of g of x as x approaches 4 from the right. Well, let's take a look at our g of x function. And here's 4. And so what's that y value there? Oh, well, it's 2, right? But we're going to go ahead and put f of 2, but here's what's really kind of interesting. I'm approaching 4 from the right, which means I'm coming from over here. I'm coming from above. All right? Now that's important. Since I'm coming from above, I'm going to put a little plus here. You might want to make a little arrow here and make a note. Since we're coming from above, I'm going to put a little plus right here. And what that means is I'm still going to be doing this as a limit. I want to find what's the limit of f as I approach 2 from above. Now, what do I mean by above, though? Here, on this graph, it's going to mean from the right. So let's come over here to the f graph. Let's find where the x equals 2. Here it is. Now, over here, since we were coming at it from above, I put a little plus here. And since there's a little plus there, that means I'm going to be approaching from the right. Okay, so since we're coming at this y value from above the y value, we're approaching that y value from numbers that are higher than this specific y value, right? Like if I'm right here at this y value and I'm coming from here, well, this is y equals 3, y equals 2.8, y equals 2.5, y equals 2.1, and then finally y equals 2. So I'm approaching this y value of 2 from y values that are above that y value. But now those y values, when I plug them in here, now they're going to act like x values on this graph. So now I'm approaching 2 from numbers that are bigger than 2, which means if you're talking about x, that means from the right. Okay? So let's go ahead and make a little note of this on another slide. But before we do, I think we can write our answer. So as I said, since we're approaching this number 2 here from the right, then we're going to choose this y value, which is 2. So the final answer here, oh, I'm sorry, it's not 2. It's y value of that point is -1. Okay, so let's review, and then I'm going to make a little note for you guys. So the limit of a composite function as we approach 4 from the right, first step is we put the limit inside. And then we find the limit of the inside function, which is 2. But we have to, since we're doing a one-sided limit, we have to ask ourselves, are we coming at this y value from above or below? Well, since we were coming from the right on this graph, that's going to be coming at that point from above, so I put a little plus there. If I was coming from below, I'd put a minus. Now, that means that when I come over here to this graph, I'm going to find what is the value of this function as I approach 2 from above. Now, above on this graph means from the right, so I'm going to be coming at it from the right. And that's what I kind of want to make a note about. All right, so here's the note with my nasty handwriting. So if we are, remember when you're doing a composite function, right, you have an outside function and you have an inside function, right? So if you are approaching the inside function's y value from above, then we will approach the outside function's x value from the right. And that just makes sense because if you're coming from above, and when you're doing graphs, right, above is a positive. So whenever you translate that into an x value, the positive value translates as a right value. So, and contrarily, if we are approaching the inside function's y value from below, we will approach the outside function's x value from the left. Okay, so let's do one more example now that we've kind of got all that regularized. Go ahead and take a look at number 2. So let's go ahead and take a look at example 4, number 2. I want to approach -3 from the right of my function f of g of x. All right, so the first thing that we're going to do, once again, is we're going to slide that limit to the inside function. And then we're going to find what is the limit of g of x as I approach -3 from the right. So here's the g function, and here's where x equals -3. And I want to approach -3 from the right side of the graph. So coming at x equals -3 from the right, we're approaching a y value of 2. But now thinking of that as a y value, yes, we were approaching the x value from the left, but thinking about it as a y value, we're approaching the y value of 2 from underneath of it, right? So we're coming at that value of y equals 2 from values of y that are less than 2. So I'm going to put a little minus there to indicate that we're coming at it from below. So now whenever I try to find f of 2, and I have 2 spots to choose from when I take my limit, I need to be approaching this. Now the 2 is going to act like an x value. That's why we're here, right? So now it's an input, so it becomes like an x value. And I need to approach this x value of 2 from numbers that are smaller than 2. Now when you're talking about x, coming at x from numbers that are smaller than it is approaching from the left. So I'm going to be approaching from the left here, an x value of 2, which puts me at this dot, which is a y value of. So there's our final answer for that one. All right, and so that is composite functions that are one-sided limits. Let's have you guys try it here. Why don't you guys go ahead and do student practice 3 here and student practice 4. Pause the video, and when you unpause it, you will see the solutions worked out for you. All right, so for number 3 here, we've got that in blue. First thing we do is apply the limit to the inside. Then we want to find the limit of g as x approaches -3 from the left, and that's what these little blue arrows are. Here's my x value of -3, and we're approaching that x value from the left of it. Now, since we're approaching from the left, we're coming at a y value of 2, and we're doing that from above. So I'm going to put a 2 with a little plus here. So now when I come over here to the f graph, we want to approach an x value of 2 from the right. So it's going to be these blue arrows here indicating that we're approaching this y value, which is -1. Let's go ahead and take a look at the pink one over here. That's number 4. To find this limit, we're going to apply the limit to the inside function. So I want to find the limit of g as x approaches 3 from the left. So here's where x equals 3, and if I come at that from the left, we're reaching a y value of 1. Now thinking of that as a y, we're approaching that y value from underneath, so we're approaching that from below. So my y value, I'm going to put a little negative there because I approached it from underneath of it. So now when I transition back over here to my f graph to find f of 1 from the left, I'm going to approach x equals 1, which is either here or here, but I'm going to do it from the left, so that means we're approaching it from here, which gives me a y value of 2. Okay, so there you have it, and we will stop there, and we'll say, see you next time.